Sorry, my phone got cut off because somebody called to tell me how I should vote. Anyway, every time you get one of these simulations, like I was just talking about, it's gonna come with a mean and a standard deviation. And you guys, those are the two things we're gonna use to get the margin of error, okay? Your homework tonight is gonna be to understand that this is a simulated bunch of SRSs. Somebody went and got, for this one, 300 different SRSs. In class, we only got a few of them the other day, and we made a little dot plot. This is 300 of them simulated. They center over our mean, and then we're going to use the mean and standard deviation to make this margin of error thing happen. Okay, so I want you to go down here. Carolina, my girl Carolina found 32 out of 50 students admitted to texting. Her proportion was 0.64. They did the simulation with 300 different SRSs, and they got a mean of 0.638, which is real close to the 64%, and a standard deviation of 0.067. All right, let's go to the next page here, and here we go. Here is estimating the margin of error for a sample proportion. You're not going to do this part, okay? So just work with me for a minute. I'm laying down the foundation here. To estimate the margin of error for a sample proportion of size, and this is everything you would do. You would simulate the distribution of the sample proportion for many random samples. We saw two examples here. One of them was 100 and one of them was 300. Of the size n, like 50 people, using the following assumption, that the true proportion that's unknown is the same as the sample proportion when we did actually take one sample. I know that's confusing. Just stick with me for a minute. Find the standard deviation. Find the standard deviation for that simulation. Like put all 300 simulations, put the number you get into list one, and then do one variable statistics. Again, you're not going to have to do all this work. Just stay with me. Number 3, multiply the standard deviation from the simulation by 2 to get the margin of error. The margin of error is the standard deviation times 2. In about 95% of all samples, the distance between the sample proportion that you get and the actual population proportion. Now, why would you get something different? Because of sampling variability. You're not guaranteed to get the right answer when you take a sample. What we're saying is, how far away could we be? 95% of all the times you do samples as a result of sampling variability, the distance between your sample proportion and the actual population proportion will be less than the margin of error. 95% of the time, your sample proportion will be less than the margin of error away from the population proportion. Okay, so let's go back to the left-handed person example. The standard deviation we found in our calculator was 2.46. That was S of x from that example earlier. So the margin of error for the proportion of lefties is just this simple. This you will do, okay? You're given a standard deviation. You go 2 times 2.46, and you get 4.92. That is our first margin of error. 2 times the standard deviation from all of those simulations. Interpretation. Now this you're going to have to do as well. Multiply this by 2 and do an interpretation. Okay, we expect the sample mean of x bar equaling 5.31, that's what we got when we took a sample, to be less than 4.92 lefties, I guess is my unit of measure there. Lefties away from the mean. Okay, let's talk about Carolina and texting. The standard deviation for Carolina's problem was 0.067. We wrote it down on the other page. So the margin of error for her proportion of students is 2 times 0.067 or 0.134. Okay, that's your job, is to do two things, guys. Multiply the standard deviation from the simulation by 2, and then just interpret what it means. Okay, here's our interpretation. This right here is the margin of error. I'm going to abbreviate that because I'm tired of writing it. We expect the sample proportion that she got, 0.64, we expect her sample proportion to be less than 0.134 people away, no, percent away from the population percent. There is a percent of people who text in her school. She took this one survey and she got 64%. We did a whole bunch of simulations of what might happen if 64% was true. We did that so we could get a standard deviation. We multiplied it by 2, and we got this margin of error right here. And what we expect is, the sample proportion she got is less than this far away from the true unknown proportion. That's what the margin of error means.